Welcome friend for the online lecture series on unit number 5. Today we are going to discuss the interesting topic in a computer graphics, that is nothing but the animation. Whenever we are viewing any animated movie, we are using the concept of animation. If you are watching any cartoon, it is made it is constructed with a mechanism of animation. So today we are going to see what are the different methods, ways by which we can have the animation. On this particular topic, my dear student, you will have one theory question in your end sem exam. So what is animation? The animation is nothing but a moving picture. Animation refers to the movement on a screen of a display device created by displaying the sequence of still images. As we have discussed previously, the animation is nothing but a still image, but those still images are in a motion. The animation is a technique of designing, drawing, making the layouts and preparation of photographic series which are integrated into multimedia and the gaming product. A person who creates the animation is called animator. He or she used the various computer technology to capture the picture and then to animate this in this desired sequence. The animation includes all visual changes on a screen of display device. Now we will see what kind of a changes we are going to have. If you are going to have a change in a shape like this, which is shown in the figure number A, if you are having this sad face, with unhappy face, then the sad, then the sorrow, then the smiley, and then the laugh space. If you can have this kind of a sequence of an image by pressing a key, then it can be termed as an animation. Then by changing the angle as well. Now if you are changing the angle, still it can be termed as the animation. If you are changing the size of an object, or you can change the color present in an object, or you can change the structure, that can be termed as your animation. Now we will see a graphic pipeline. What is the concept of graphic pipeline? My dear student, the graphics pipeline handles only a simple primitive by design points, line, triangles or chords as a true triangle. Efficient algorithms, the pipeline names derived from the architecture design, the sequence of stage which define input and output, easy to optimize the modular design. In graphical pipeline, the object local algorithm processes only one surface at a time. The various effect has to be appropriate. For example, the shadow volume and the shadow maps. Then we have to generate the reflection, the environment mapping, and these two concepts, shading and reflection, is hard to implement. Advanced effect cannot be implemented. The soft shadow, the blurry reflection and the diffusion in indirect illumination. The example of graphics pipeline, when we are capturing any image with the help of our mobile, you will find nowadays we are having the blurring effect. To produce this blurring effect, we are in the need of graphic pipeline. We will see in detail in next slide. Graphic pipeline stage. My dear student, this question is quite important as far as your university paper is concerned. Kindly have a note of this. In graphic pipeline stage, we will have the vector data. Then the vector data is processed with the transformation. With the help of this transformation, we will get the transform vector data. Now this transform vector data is converted to the pixel with the help of clipping and rasterization. Then the fragment interpolated data. Finally, we compute the color with fragment processing, the fragments color and depth with the blending of hidden surface, frame buffer processing and frame buffer. So what is this vector processing? Vector processing is having the input as the vector, the position, normal or color, output, transform vector in the homogeneous, applied a transformation from the object space to the clip space passing along with the material data. Clipping and rasterization turn the set of vertex into a primitive and they film them in. The output is the set of fragment with the interpolated data. The fragment processing, the output, final color and depth. They traditionally mostly for the texture lookups. The lightning was compute for every vertex. Today computes the lightning the per pixel. Frame buffer processing, output is final picture hidden. The surface elimination, the composition via the alpha binding. Graphics pipelining, for each object, for each pixel we have to process the project, we have to project the output onto a pixel. We have to uh, describe describe the pixel. We can access only one object at a time. The image must fit in a memory first before we can process it. The graphics pipelining, it is hard for a complex effect. As we are talking about the complexity of graphical pipeline, so it is denoted with the big O of n, but constant is very small. Now we will discuss about the block diagram of Intel i860. My dear student, you will observe an alternative question. Write the short notes or explain block diagram of Intel i860. So this is the block diagram of Intel i860. So here you will find that it is 64-bit of processor. Here parallel architecture that support up to a 3 operation per clock, 1 integer or a control instruction per clock, up to 2 floating point result per clock, high performance design, 33 or 40 megahertz clock rate is there, 80 pix signal precision MFLOPS is there, 64-bit external data bus, 64-bit internal instruction cache bus, 128-bit internal data cache bus, high level of integration on one chip, 32-bit integer and the control unit, 32-bit or 64-bit pipeline floating point adder and multiplier unit, 64-bit 3D graphic unit, the paging unit with a translation look-aside buffer, 4K byte instruction cache, the compatible with the industry standard as well, IEEE standard 7541985 for the binary floating point arithmetic, 386 or 486 microprocessor data format and the paging table entries, easy to use, one chip debug register, assembler, linker, simulation, debugger, C and Photon, the compiler, both OS2 or the Linux environment is supported by this particular Intel i860. Thank you for listening. With this, we have done with our unit number 5. If you are having any doubt, you can contact me on Google Classroom. Thank you.